Hello everyone, class 12. Topic is Saytzeff rule during dehydration of alcohol. What that rule is saying, if alcohol during dehydration is able to generate more than one type of alkene, more stable alkene will be the major product. As you know, we are dealing with dehydration of alcohol at 433 Kelvin temperature to 443 Kelvin temperature. In this temperature, during dehydration of alcohol, alkenes are generated. If suppose alcohol is able to generate more than one type of alkene, so according to Saytzeff rule, more stable alkene will be the major product. This rule actually we have already discussed in haloalkane chapter. Let's try in alcohol now. For that, suppose I am using this alcohol. This is butane 2-ol. Now whole mechanism I will not show. I will directly dehydrate it. We know what is the condition required for dehydration. Sulfuric acid is required as a catalyst. Temperature ranging from 433 Kelvin to 443 Kelvin. Now, what was the technique I have told you? This OH, dehydration means release of H2O, water molecules. So this OH and the carbon next to OH carbon, like this is the carbon of OH, next carbon, this carbon, H from here. Just release out H2O and make bond between these two carbon. Alkene will be generated. So if I am releasing this H and this OH, alkene generated will be this. Check. This is as it is. This will remain as it is, CH2. And between these two carbons, double bond will generate. One more hydrogen will be there. Check. This one. What is the name of this alkene? If I will do IUPAC naming, I will find its name will be but1-ene. But1-ene. Okay. Can we make another alkene? Yes. OH carbon is this. Check on left side one more carbon is there, this one. If we are removing this hydrogen and this OH, bond will generate between these two carbons. Let's check which alkene will generate. CH3 as it is. Between these two carbons, bond will generate. This CH3 as it is. This one. What is the name of this alkene? But2-ene. That's it. Only these two type of alkenes you can generate with this alcohol after its dehydration at this temperature. I have not shown complete mechanism. Already we have done it. You can check the previous videos. I am talking only about Saytzeff rule. Now out of these two alkenes, which will be major? It depends on stability of alkene, and stability of alkene will be tested directly depends on number of alpha hydrogen atoms. Due to alpha hydrogen atoms, alkenes are able to show hyperconjugation, and hyperconjugation leads to the stability of alkene. More hyperconjugation, more stability. So, number of alpha hydrogens will decide stability of alkene. What are alpha hydrogens? You can check. This is double bonded carbon. These two are double bonded carbon. Next carbon to them are known as alpha carbon. These are alpha carbons. Doubly bonded carbon, next carbon to it, it is alpha carbon. Doubly bonded carbon, next carbon to it, it is alpha carbon. And the hydrogens which are attached to alpha carbons are known as alpha hydrogens. So you can check in this case, 6 alpha hydrogens are there. Butene have 6 alpha hydrogens. And if we talk about this side, so this is double bonded carbon. This carbon, this is alpha carbon. How many hydrogens it is carrying? 2. This side we do not have any alpha carbon. So but1ene have only 2 alpha hydrogens. That's it. It is carrying 6 alpha hydrogen, 6 times hyperconjugation. It is carrying 2 alpha hydrogen, 2 times hyperconjugation. Means this alkene is more stable and this alkene will be less stable. So according to Saytzeff rule, this will be our major product and this will be our minor product. Means this alkene will generate in lesser amount and this alkene will generate in major amount. That's it. This was the topic. And let's take one more example. This one. So after dehydration, please check how many type of alkenes are possible. OH is connected to this carbon and neighboring carbon. Let's take this carbon first. OH and H remove out from here and make double bond between these two. The alkene generated will be this one. OH connected to this carbon and this carbon is connected with this hydrogen and this OH remove out. Then check what kind of alkene will generate. Now double bond will generate between these two carbons. Rest part as it is, this one. Out of these two alkenes, which will be major alkene, please check. Number of alpha hydrogens, let's count. In this case, we have only this carbon as a alpha carbon. It is carrying 1 hydrogen. So only 1 time hyperconjugation. And here, these are doubly bonded carbon. This is alpha carbon. This is alpha carbon. And this is alpha carbon. So here 9 times hyperconjugation will arise. So this alkene will be the major alkene and this alkene will be the minor alkene. Please try more exercises about this topic. Thank you very much for watching the video.